First Law of Thermodynamics, Skill Practice 53 by Andrew Lee. Practice problem number 1. Calculate the enthalpy change for the following reaction. By using a table of standard enthalpies of formation, you can solve for delta H. Look at the product side first. You take the delta HF of H2O and times it by 4 plus the delta HF of CO2 times 2. Then you look at the reactant side and take the delta HF of CH3OH and times it by 2 plus the delta HF of O2 times it by 3. Then you do products minus reactants and get negative 1452.2 kilojoules. Problem number 2. Calculate the enthalpy change for the decomposition of 1 mole of SO3. First you write the reaction of the decomposition of SO3 and balance it out. You get 2SO3 goes to 2SO2 plus O2. Then, since you're solving for 1 mole of SO3, you divide the entire reaction by 2 and get SO3 goes to SO2 plus 1 half O2. Then you just solve for delta H like you've done before and get an answer of 99.1 kilojoules. Problem 3. Solve for delta H using a table of standard enthalpies of formation for 1 mole of MgCO3, which gets you 117.7 kilojoules per mole of MgCO3, just like how we've done before. You then find the molar mass of MgCO3, which is 84.315 grams per mole. When finding the enthalpy change of MgCO3, you take the delta H and multiply it by the inverse of the molar mass to get the moles to cancel, and then multiply it by the mass of MgCO3 to get the grams to cancel. And then you get the enthalpy change of MgCO3 in kilojoules with a final answer of 76.3 kilojoules. Problem 4. When trying to figure out whether a reaction is exothermic or endothermic, you only have to worry about the sign of the delta H, not the actual value. So using a table of standard enthalpies of formation, you can solve for the sign of delta H. A negative minus a positive gets you a negative, so it is exothermic. B. A negative plus a negative minus a positive. B. Negative plus a negative minus a positive gets you a negative, so it is exothermic. C. A positive minus 0 gives you a positive, so it is endothermic. Problem 5 requires you to use Hess's law and manipulate the reactions for it to work. Using the given information, you want to get 4NH3 plus 5O2, which goes to 4NO plus 6H2O. So first you want to write the inverse of reaction B because NH3 is on the left side. When you flip the reaction, you have to flip the sign of delta HF too. After you find the inverse of reaction B, you have to multiply the entire reaction by 2 in order to get 4NH3. Just like inversing the reaction makes you do the same to delta HF, multiplying the reaction means you have to do the same to delta HF. When you do that, you get 4NH3 goes to 2N2 and 6H2. So next you want to get rid of the 6H2. So you take reaction C and multiply it all by 3. And don't forget about the delta HF2. Next you want to get rid of the 2N2. So you take the reaction A and multiply everything by 2. After you multiply everything out, you can rewrite the reactions and then add them all together, which means you can cancel out like terms from both sides and add like terms from the same side. The 6H2 and the 2N2 are gone, and the 3O2 and 2O2 add to get 5O2. When all that is done, you get the final reaction of 4NH3 plus 5O2, which goes to 4NO plus 6H2O. And then you're able to add the delta HF to get you a change in enthalpy for the reaction, which gives you an answer of negative 906.3 kilojoules. Congratulations, you have now learned about the first law of thermodynamics. Have fun with the rest of chemistry. Andrew Lee is cool.